I'm 65 years old, still balling. Probably got osteoporosis, but I don't know it. Watch me lock this young man up. My hip! Oh, my hip. If only there was a way. I could have known I was at risk of breaking my hip. Risk Ray.
Luckily for our colleague Adam, there is a platform that we've just developed that can help prevent that situation from happening again in the future. Our platform, RiskRay, is a data and machine learning platform used to assess the bone density and severity of osteoporosis of a patient, which can be used to help doctors assess the risk of a hip fracture using only an X-ray as opposed to expensive DEXA scans. Our platform can be divided into two parts. On the left, we have a user-facing application where a doctor can upload a patient's X-ray to be sent to our cloud platform, which can then perform some analysis and yield back the results of the patient's risk assessment. Let's go through the journey of how information travels throughout our infrastructure and is yielded back to the doctor into a useful conclusion. First and foremost, using our user interface, the doctor would upload an X-ray scan of the patient's hip. The doctor must also specify regions of interest through a set of X and Y coordinates for the left hip and the right hip. Next, once uploaded, an AWS Lambda function is triggered to pre-process our images. The goal of this section is to ensure that we are comparing apples to apples by standardizing the data passed to our system. So first, the X-ray image itself has its brightness normalized based on the X-ray's measured light intensity value, per the code snippet at the bottom. Next, specified coordinates are examined, and we crop the X-ray accordingly so that only the femur is examined. The cropped images are then zero padded to match a standardized size associated with the remainder of our dataset. This resulting data is then stored in a cloud data store, specifically in an AWS S3 bucket. Next, this modified data passes through our trained risk prediction model, which runs on a remote server, namely through an AWS EC2 instance, and returns a risk assessment to the user. The risk prediction model is a trained convolutional neural network, and so it tends to perform better as the number of data points provided to the model increases. Therefore, when new X-rays are uploaded by a doctor, they are also used to retrain our convolutional neural net and improve future performance, which is the infrastructure highlighted on the right.
We are now going to show you what a doctor would see when they use RiskRay. First, the doctor would log into the RiskRay website. Once logged in, they can upload a new X-ray file for analysis. After uploading the X-ray file, the doctor then crops the X-ray by inputting X and Y coordinates. This greatly increases the effectiveness of the machine learning model and lets doctors highlight important areas for the model to focus on. Once the doctor is completed, they are able to upload the X-ray to our data pipeline where it can be processed. Our machine learning model will then predict a percentage likelihood of hip fracture and return it to the doctor. Now, the doctor has another tool in order to assist them in determining the next best steps for the patient.